Ever wonder what's really behind AI's most incredible achievements? From your voice assistant to self-driving cars? Well, the engine driving all of that is called deep learning. It's this powerful technology that teaches machines to learn in a way that's, well, it's actually inspired by our very own brains.
Think about this for a second. You snap a picture, and your phone almost instantly tags it as a cat. It honestly feels like magic, right? But it's not. It's deep learning at work. And by the end of this, you'll know exactly how it pulls that off.
All right, so here's our game plan. First, we're going to nail down what deep learning actually is. Then, we'll see how computers learn. We'll take a quick tour of the different models, find out where it's hiding in our daily lives, and finally, we'll look at the good and the bad, its power and its pitfalls.
Okay, first things first. Let's get our bearings. Where does deep learning even fit into the whole world of technology? It really helps to think of it like a set of those Russian nesting dolls.
So that biggest doll, the one on the very outside, that's artificial intelligence, AI. This is the whole grand idea of creating machines that can think and act intelligently. It's a huge, broad concept.
Now open up that AI doll, and inside you find machine learning. This is a specific way of doing AI. Instead of programming a machine with a million explicit rules, we just feed it a ton of data and let it figure out the rules for itself.
And then, at the very heart of it all, inside the machine learning doll, is deep learning. It's a super specialized, really powerful type of machine learning that uses something called deep neural networks to find patterns. Think of it as the engine inside the engine.
So what does that really mean? Well, deep learning uses these layered structures called neural networks, which are, believe it or not, inspired by the neurons in our own brains. This lets the machine learn directly from raw data, like all the pixels in an image, without any human having to step in and tell it what specific features to look for.
So how in the world does this actually work? Let's go back to our cat photo to make this real. How does a machine possibly go from just a bunch of pixels to recognizing your furry best friend?
It all kicks off with the input. We take the raw image data, which is really just a big grid of numbers representing colors and brightness, and we feed it into the first layer of this neural network.
The process starts simple, really simple. The first layer doesn't see a cat, not at all. It just learns to recognize the most basic things, like edges, straight lines, curves, basically the fundamental building blocks of any image.
Okay, so then the output from that first layer gets passed along to the next one. The second layer takes all those simple lines and edges and starts combining them. It learns to see more complex shapes, like, hey, that pointy triangle could be an ear, or those two circles might just be eyes.
And this is where the deep in deep learning comes from. As the data moves deeper and deeper into the network, each layer builds on the one before it, learning more and more abstract concepts. It's how the network starts to assemble those simple ears, eyes, and nose into the recognizable pattern of a cat's face. And finally, after passing through all these layers of analysis, the last layer takes all this assembled information and makes a final call. Based on everything it's learned, it calculates a super high probability that all the features it detected, well, they match the pattern for cat.
And here's the real game changer. With older methods, a human programmer had to sit down and tell the computer exactly what to look for. Look for pointy ears, look for whiskers. Deep learning figures all of that out entirely on its own. It's the difference between following a recipe and actually inventing one from scratch.
But, deep learning isn't just one single tool. It's more like a whole toolbox filled with different models, and each one is a specialist for a different kind of problem. For instance, you've got CNNs, which are absolute masters of images and video. They power that cat detection we just talked about. Then there are RNNs and LSTMs, which are great with sequences, like the words in a sentence, making them perfect for translation apps. And of course, you have transformers, the powerhouse architecture behind models like ChatGPT, which are incredible at understanding complex language.
Now, while all this might sound a little abstract and techy, the truth is this technology is already woven right into the fabric of our daily lives. I mean, you're using it when you talk to Siri or Alexa, you're using it when your social media feed automatically tags your friends in photos, or when your bank flags a weird transaction. It's being used in healthcare to spot diseases in scans earlier than ever, and it's the core tech that lets self-driving cars actually see and understand the world around them. It's everywhere.
But, like any really powerful technology, deep learning isn't perfect. It comes with some pretty significant challenges and trade-offs.
So on the one hand, its ability to learn on its own and get incredibly accurate results is just undeniable.
But on the other hand, it needs a ton of data to learn from, and it requires some seriously powerful computers. And maybe the biggest issue is that its decision-making can be a black box, making it really hard for us to understand why it made a certain choice. And that becomes a huge problem when it's making critical decisions in fields like medicine or finance.
When you step back and look at the big picture, deep learning isn't just a slight improvement on an old method. It represents a completely different, fundamental shift in how we think about programming computers.
Think about it like this. Traditionally, a human programmer writes the rules, feeds in data, and the computer spits out an answer. With machine learning, we flip that completely on its head. We give the computer the data and the answers, thousands of cat pictures all labeled cat, and the machine figures out the rules for itself.
This new way of doing things is why deep learning is so foundational today. It's the absolute backbone of modern AI systems, powering everything from self-driving cars to those mind-blowing generative AI models. It is the core technology, making it all possible.
So, we've given machines this incredible new way to learn from the world, a way that kind of mirrors our own ability to see patterns. It's an unbelievably powerful tool that's already reshaping our world, which leaves us with the biggest question of all. What's the most important thing we should teach them next?